explained. Before life began on Earth, before even the planets existed, our sun was born from the darkness of space. A colossal ball of fire, giving light, warmth, and energy to everything in our solar system. But have you ever wondered, how did this gigantic star come into existence? How did a cloud of gas and dust transform into the blazing sun that we see today? In this video, we'll travel back 4.6 billion years, to witness the birth of the sun and uncover the secrets of how our solar system began. Long before our sun existed, the universe was already filled with countless stars, many older than ours. When these massive stars reached the end of their lives, they exploded as supernovae, scattering their outer layers into space. These explosions released clouds of gas and dust, mostly hydrogen, helium, and heavier elements like carbon, oxygen, and iron. Over millions of years, these materials floated through space, forming enormous clouds known as nebulae. Our sun's story begins inside one such giant molecular cloud, a cold, dark region of space filled with dust and gas roughly 100 light-years wide. It was a quiet place, until something disturbed the peace. Perhaps it was the shock wave of a nearby supernova, or the gravitational pull of a passing star. Whatever the cause, this disturbance sent ripples through the cloud, causing parts of it to collapse under their own gravity. And that's where the magic began. As gravity pulled the gas and dust inward, the material began to spin, forming a dense core at the center. This spinning motion flattened the surrounding gas into a disc-shaped cloud, known as a protoplanetary disk. At the heart of it, the collapsing material heated up. Temperatures climbed from just a few degrees above absolute zero to thousands of degrees. A glowing ball of gas began to form, called a protostar. This was the earliest version of our sun. The protostar wasn't shining yet like today's sun. It was mostly glowing from heat and pressure caused by the collapse. It continued to grow, feeding on material from the disk around it, getting hotter, brighter, and more massive with every passing million years. Eventually, the pressure at the protostar's core became so immense that the temperature reached about 10 million degrees Celsius. And then the most important event in the sun's life occurred. Nuclear fusion began. Inside the core, hydrogen atoms fused together to form helium, releasing enormous amounts of energy in the process. This energy pushed outward, balancing the inward pull of gravity. At that exact moment, our sun was officially born, a main sequence star. The balance between gravity and fusion created a stable, shining star that would last for billions of years. Its light began to spread across the surrounding disk, pushing away leftover dust and gas, and illuminating the newborn solar system. While the sun came to life, the remaining dust and gas in the protoplanetary disk didn't vanish. Instead, tiny particles began to stick together, forming clumps, rocks, and eventually, planetesimals, the building blocks of planets. Over time, these planetesimals collided and combined to form the planets, moons, and asteroids we know today. The inner region close to the sun became hot and dry, forming rocky planets like Mercury, Venus, Earth, and Mars. The outer regions were colder, allowing gases like hydrogen and helium to remain, forming giant planets like Jupiter and Saturn. So, in a way, the birth of the sun didn't just create a star. It created the entire solar system. In its youth, the sun wasn't as calm as it appears today. It spun faster and produced stronger solar wind streams of charged particles that blasted into space. These powerful winds blew away much of the leftover gas and dust, shaping the final structure of our solar system. For the first few 100 million years, the sun's brightness was only about 70% of what it is today. Scientists call this the faint young sun paradox. Despite being dimmer, early Earth still had liquid water, possibly due to greenhouse gases trapping heat in the atmosphere. Slowly, the Sun stabilized its fusion reactions balanced perfectly with gravity, allowing life to eventually emerge on one of its planets, Earth. Today, our Sun is a middle-aged star, about 4.6 billion years old. It's in the prime of its life, fusing hydrogen into helium in its core, radiating energy that travels 150 million kilometers to reach Earth. Every sunrise we see is a reminder of that ancient birth in the depths of the universe. The Sun provides light for photosynthesis, warmth for life, and energy that drives our weather and climate. It's a cosmic engine keeping our entire solar system in balance. But like all stars, the Sun's life won't last forever. Billions of years from now, the Sun will begin to run out of hydrogen fuel. Its core will shrink, and its outer layers will expand, turning the Sun into a red giant. During this phase, it will grow so large that it might engulf Mercury, Venus, and possibly even Earth. After that, the Sun will shed its outer layers into space, creating a beautiful glowing cloud called a planetary nebula. What will remain at the center will be a white dwarf, the small, dense, fading core of what was once our Sun. Every atom in your body was once part of a star, maybe even part of the cloud that formed the Sun. So the next time you feel the warmth of sunlight on your face, remember you're feeling the glow of a 4.6 billion-year-old miracle. The very star that made life possible. Our Sun, the heart of our solar system, and the eternal fire of our origins.